Hello, today we will discuss lifting exponent lemma, sometimes known as Hensel's lemma. In this case, Vp of any number x equals alpha. This means that p to the alpha divides x, and p to the alpha plus 1 does not divide x. In this case, Vp of a to the n minus b to the n must be equal Vp a minus b times a minus b plus Vp of n. And to fulfill this equation, we need to have a and b not multiple of p, and a minus b must be divisible by p. At first, to prove this, we can discuss some basic properties, and if n is not divisible by p, because a minus b is divisible by p, this means that a equals b mod p. And look at a to the n minus b to the n. This number equals a minus b times a to the n minus 1 plus b times a to the n minus 2 up to b to the n minus 1. And because we know that Vp of x times y equals Vpx plus Vpy, we can see that the Vp of a to the n minus b to the n, this must be Vp of a minus b plus Vp of a to the n minus 1 up to b minus 1. B to the n minus 1. And now let's see what must be the remainder of this number mod p. Because we know that a equals b mod p, we can write as a to the n minus 1 plus up to b to the n minus 1. This number equals a n minus 1 times a to the n minus 1 plus a to the n minus 2, because instead of b we can write a in mod p, and n minus 1, and last one will be also a to the n minus 1, because b equals a mod p. So this must be n times a to the n minus 1 mod p. Because we know that a to the n minus 1 is not divisible by p, this equals n mod p. So we can conclude that this formula is correct for every number n if n is not divisible by p. And now let's discuss the case then n is divisible by p. In this case, we can discuss several versions. If Vp, or we need to count the a to the p minus b to the p, and we need to show that this equals Vp of a minus b plus 1. In a similar way, we can see that a to the p minus b, this equals a minus b times a to the p minus 1 plus a to the p minus 2 times b up to b to the p minus 1. And if we use the fact that a equals b mod p, then we can see that this number equals p mod p. So, and p is 0. And we can see that this number is divisible by p. But now we need to show that this number can't be divisible by p square. For this, we can represent b equals a plus k times p. We can use this one because they are equal mod p. And if we take a to the t times b to the p minus t, then in this case we can expand this one. This must be a to the t times a plus k times p to the t. And this, now we can expand this one. So this must be a to the t, p minus t, p minus t minus 1, p minus t minus 1, in this case, we will have a to the p minus 1 plus p minus t minus 1 times kp times a to the p minus 2. Then all numbers here must be divisible by p square, because we will have kp square times something. So these numbers are divisible by p square, so this equals a to the p minus 1 plus p minus t minus 1 times kp to the a to the p minus 2. Now we can use this to take whole sum mod p square. This sum mod p square. Then we will get a to the p minus 1 plus a to the p minus 1 plus kp times 1 times kp times a to the p minus 2, then plus a to the p minus 1 plus 2 times kp times a to the p minus 2, and all the way up to plus a to the p minus 1 plus 2 to the k times p, not 2, p minus 1 times k times kp times a to the p minus 2. And if we take this number as mod p squared, this equals p times a to the p minus 1 plus this sum must be kp times a to the p minus 2, and we will get arithmetic progression 1, 2 up to p minus 1. So this must be p minus 1 times p over 2 mod p. And in this case, if we assume that this number p is not equal to 2, we can take that this must be a positive integer, p minus 1 over 2, and this number must be divisible by p square, because we have p here and p here. So this number equals p to the ap minus 1 mod p square, and so this is p mod p square. Mod p square. And so clearly this number is not divisible by p square, because this is not 0. This is not 0. We can see that a is not divisible by p minus 1, and that's the main reason why this is not 0. And if we know that a to the p minus b to the p, this adds 1 power of p, which divides this number, we can assume that a to the p to the k will add k power of multiple of p's. So we can assume that vp of a to the p to the k minus b to the p to k equals vpa minus b plus k vp p to the k. So this must be vpa minus b plus k. And now we can use the above fact that vp of a to the n minus b to the n was vp a minus b if n is not divisible by p. So we can see that for every number our above formula works, that vp of a to the t minus b to the t must be a to the vp of a minus b plus vp of t. So we will see that this works, but now we need to discuss the case then p minus 1 equals 1 and p equals 0. In this case, the discussion is almost same, but the formula is a bit different, and I can write the formula. If you will be interested in the formula, please write in the comments and I will discuss this. v2 of x minus x to the n minus y to the n, this equals v2 of x minus y plus v2 of x plus y then v2 of n minus 1. This is almost same but a bit different, and if you forget about this one, you will lose some points at the Olympiads.